Alright, in part 2 of my tutorial, I'm going to look at the individual notes that make up specific chords. So every type of chord has its own specific formula based on the 8 notes of the key. This formula is just a specific combination of notes. So if we're looking at a major chord, it's going to use the first, the third, and the fifth note of the major scale. So if we've figured out the 8 notes that are in our key, the first note is going to be the root note, or the note the chord is named after. And then the next note is going to be the third. So in the key of C, that note will be E. So we can draw this interval from C to E. And the fifth note will be a G. And then the 8th note will be the octave, the same as the root. So that's also part of the chord. And we get this triangle shape, which is the relationship of all the notes in a major triad. And we can rotate this around the circle. If the root note is D flat, our third and fifth would be F and A flat. So these are the notes that make up a D flat chord. A D chord is D, F sharp, and A. And E flat is E flat, G, and B flat. E is E, G sharp, and B. F is F, A, and C, and so on. G flat, G, A flat, A, B flat, B, and back to C. The major chords all have this same kind of sound because they all have exactly this triangle relationship. The only difference is that they start at a different pitch. For a minor chord, the formula is the 1, a flattened third, and the fifth. So in the key of C, it's the same as a major chord except the third note in the scale has been flattened. So here it'll be C, E flat, and G. And this gives you a similar triangle, but with a slightly different relationship. So all minor chords look like this one. A sus2 chord means you take the first, the second, and fifth notes of the scale. So here in the key of C, we would have C, D, and G, which looks like this. And then a sus4 chord means it's made of the 1, the 4, and the 5. So in the key of C, we would have C, F, and G, which looks like this. So all these chords are very similar. All four, the root and the fifth stay the same, and it just really depends what the middle note does. And whatever the chord is, the relationship between the notes is going to remain the same. It'll give it the same shape no matter where it rotates around the circle. So these are all sus4 chords. Okay, let's have a look at some chords that have 4 notes now. The most common would be a dominant 7th chord, which we simply know as a 7th. And this is the same as a major chord with the 1, 3, and the 5, and then we add the flattened 7th. So in the key of C, the notes will be C to E to G, and then we add the B flat. And then we can join it up with the octave C. And this gives us a 4-sided shape. Every 7th chord will look just like this, rotated around the circle. For a major 7th chord, the formula is the same, except it's a natural 7th, not a flattened one. So in the same key, the notes are C, E, and G as the major chord, plus a B this time, which joins up to make this shape. Now, a minor 7th is a minor chord with a flattened 7th. So it's the 1, the flattened 3rd, and the 5, and the flat 7th. So in the key of C, we flatten the 3rd to make E flat, and then we add the B flat, making this shape. For a 6th chord, it's a major chord 1, 3, 5, plus the sixth note in the scale. So that's C, E, and G, and then we add the A. But have a look at these two different shapes. They're actually exactly the same. They're just rotated around differently. If I take the C minor seventh on the left and roll it back a few steps, B minor seventh, B flat minor seventh, A minor seventh, and now they're both exactly the same notes, exactly the same shapes. So an A minor seventh is the same as a C sixth. And ukulele players know this because the chord that the uke is tuned to, you don't need any frets to strum either of those chords. But now you know why they have two different names. The four notes are in the same relationship to each other, and it just depends what you're calling your root note and which formula you follow to stack the next three notes into the chord. So every minor seventh will be the same as a different sixth chord. It follows the relative minor of the scale. So in the key of C, the relative minor is A minor, so a C6 is the same as an A minor seventh. If it was the key of G, the relative minor is E minor, so a G6 is the same as an E minor seventh, and so on. Now these next two chords are chords that confuse a lot of people. The first type is an augmented chord. The formula is to take a major chord and sharpen the fifth. So it's 1, 3, and a sharp 5. So in our C scale, it would be C, E, and G sharp. And if we draw it, it looks like this. It's a perfect equilateral triangle. But this means that if you take your C augmented, it's exactly the same as an E augmented, which is exactly the same as a G sharp augmented. If you imagine rotating this triangle around, it's going to land on the same notes again every time the corners match, whether the note is C, E, or G sharp. So if you see any of those three chords, you'll just play exactly the same shape on the ukulele because it's the same chord, just three different names. And then if we drew in the C sharp augmented, it's the same as the F augmented or the A augmented, because it's the same three notes in all three chords. And the same with the D augmented, the F sharp augmented, and the B flat augmented. And finally, it'll be the same with the E flat augmented, the G augmented, and the B augmented. So that's all 12 different chords, but there's only 4 different shapes there. If you look up an augmented chord shape, they're all going to look exactly the same, except they either start on the first, second, third, or fourth fret. So there's only 4 of them, and all you need to know is to know where to find the note that they're mentioning, and you'll be able to play one of only 4 positions. Diminished chords, they also seem a bit tricky. The basic formula for them is a flattened third and a flattened fifth. So for a 3-note chord, a C diminished would be C, E flat, and G flat, which would look like this. But the most common diminished chord is actually a diminished seventh. And this means it's a diminished chord with a flattened seventh. It's a flattened dominant seventh. So we take our usual seventh, which is a flattened seventh, and we flatten it again. So it's double flattened. Now, I know this sounds weird. I don't really understand it myself, but you just need to accept that it exists. So instead of the usual flattened seventh, which would be a B flat, we're going to flatten it again to make an A. I don't know why it's not called a diminished sixth. I didn't make up the rules. But we're going to draw it now like this. C, E flat, G flat, and A, coming back to C. And this makes a perfect square. So a bit like the previous example, if we rotated this chord a few times, we'd get 4 different names this time for the same 4 notes. So this one could be a C diminished seventh, an E flat diminished seventh, a G flat diminished seventh, or an A diminished seventh. If we sharpened it all by a semitone, we'd get C sharp diminished seventh, E diminished seventh, G diminished seventh, and B flat diminished seventh. And then one more semitone, we'd get D diminished seventh, F diminished seventh, G sharp diminished seventh, and B diminished seventh. So each square has 4 different chord names, and there's only 3 different chords in total before it all repeats. So really, even though this is seen as a difficult chord and it confuses a lot of people, there are only 3 identical shapes that you need to learn, all 1 fret apart, and then you'd have all 12 chords covered. Okay, look, there are other examples of chords that are exactly the same as other chords, especially when you start mixing up combinations of major sevenths or sus chords and minors and sixths, etc. They'll have different names because their starting corner is different, but when you draw them out, they're going to form identical geometric shapes which will have the same corner notes. That's why it's the same chord. So I hope this way of visualizing the notes has been useful and helped you to picture how music's put together. And hopefully this music theory has become a little bit less daunting. Thanks for watching.